Good afternoon, all of you. This lesson for grade 12. Notes on Ionic Equilibrium. We are going to start today third unit, Ionic Equilibrium, and these are the objectives what we are going to learn. The first one, recall the definition of equilibrium, then write the dissociation of reaction of water, and the third one is write the expression of Kw, then work out its unit. So till here we will start first. Then come in here that what is equilibrium. First we want to define what is equilibrium. A chemical reaction is in equilibrium when the reaction of reactant and product are constant and their ratio does not change or vary. And another way of defining equilibrium is to say that equilibrium is rate of forward reaction is equal to rate of backward reaction, because we can define equilibrium both way. Either you can take the amount of reactant or concentration of reactant and product, and the second one you can use the rate of forward reaction as well as rate of reverse reaction. When amount or concentration of reactant and product are equal, or the rate of forward reaction and rate of backward reactions are equal, that state is known as equilibrium state. Here another example, these types of reaction we can observe only in reversible reaction. So equilibrium can only be obtained in a closed system. We have two types of system, closed system and open system. Closed system, we can study the reversible reaction. We cannot use here open system because we need reversible reaction. This diagram, you can see this one a beaker, and there is inside a solution, and this, when we heat this solution, it will start evaporation. But you know that we close from the top. When we close, it means it can return back. Evaporation and condensation process here. So these types of reaction are known as equilibrium. Reversible reaction and state is known as equilibrium. Then we have more explanation about the equilibrium. Let's take one example of this carbon dioxide when react with water molecule, and it will produce carbonic acid, H2CO3. There are many examples, but we will take only one example. This reversible arrow, its mean reaction is going forward and backward both way. Now the next B, C and D, we have three objectives. The first one is write the dissociation reactions of water. Then write the expression of Kw. Kw actually we call K for constant and W for water. Then work out its unit. State that only a factor that affects the value of Kw is temperature. So let's see here how we dissociate the water molecule. When you write a dissociation constant in which the compound breaks into a component ions, you place a chart above the ion symbol and the balanced chemical equation. The reaction in which the water breaks down into hydrogen and hydroxide ion is a dissociation reaction. Dissociation means breakdown. Any molecules or compound break down into its ionic state. We call dissociation constant. Look at here, the water molecules break down into hydrogen and hydroxide ion. Look at the board how to break water molecule. H2O is present in the liquid form and aqueous, and when you break down, it will dissociate into hydrogen ion plus hydroxide ion, we can call hydroxide. Then here both are in aqueous solution, and this reversible arrow represents that this reaction is going forward as well as backward. So here this half arrow represents forward reaction. We can write F for that, and this backward, or you can call reverse reactions. When we want to write for this Kw expression, that is known as ionic product of water. Ionic product, why we call? Because hydrogen is positive here and hydroxide is negative. That's why we will call ionic product of water. Applying the law of mass action to write the expression, for constant. Then how to write the value for K? First we write the product over reactant. Concentration of, you can say concentration of product over concentration of reactant. Concentration of reactant. You can write here equals mean at equilibrium state. Because we are going to study for water, that's why we can use here W. This W means ionic product of water. Kw is known as ionic product of water. Now, by using this equation, we are going to write product over reactant. So, here hydrogen ion H plus, and then we have hydroxide ion OH minus over. You can write the water. Actually, we will not use if something or any compound or molecule present in a solid and liquid state. We cannot write in equilibrium expression, but if you want to write H2O, but it will not work in this physical state. So you can cancel this one and then write Kw is equal to concentration of hydrogen ion to concentration of hydroxide ion, and this expression is known as ionic product of water Kw. Let's see here. It's given there here. Kw is equal to H plus into OH minus over water. So because we will take as a constant, so since look at here, hydrogen ion and hydroxide ion is equal to Kw. The constant Kw is termed as ionic product of water. So our first objective is, what is ionic product of water? So ionic product means concentration of hydrogen ion and concentration of hydroxide ion we call ionic product of water. Now, the second our objective is given there, this Kw value affected by temperature. When we increase temperature or we decrease temperature, Kw value will change. Look at there is one example here, the product of concentration of hydrogen and hydroxide ion in water at a particular temperature is known as ionic product of water. The value of Kw increase with increase of temperature. That is, the concentration of hydrogen and hydroxide ions increase with increase in temperature. Example given here, look at the 0 temperature. You can take a degree Celsius. The value of Kw at 0 is 0.1 and 10 raised to the power minus 14. At 10 you can see the value of 25 degrees Celsius and 100 degrees Celsius. When you increase the temperature, the Kw value also increase. The value of Kw at 25 is 1 power minus 14. Since pure water is a neutral in nature, hydrogen ion concentration must be equal to hydroxide ion concentration. Look at here, both concentrations are equal. Why? Because if we use the pH scale, so pH scale we will start from 0 to 14. Here 7. Here water. The pH of water 7 is mean neutral. Before 7, from here to here we call acidic. And from 7 to 14 we call basic. And acidic means those substances they donate or they produce H plus according to Lorentz and Bronsted theory, and those substances produce OH minus we call base. So actually the water is ionic product of acid and base, and it can we have both way we call amphoteric in nature. Look at here one example. The value we will take from the pH curve 10 power minus 7, because here for hydrogen and for hydroxide ion, for both, because both are equal, H plus is equal to OH minus, and the value is 1 10 to the power minus 7. Because both concentration equal, so we can write same value.
Better is not same.
Now, in the next, we will use here, as I wrote and I explained you before that before acidic and basic, you can see here, and I want to show you here that acidic here ion product of water, it will dissociate and then we write Kw as we did before. Now we want to divide it pure water, acidic solution and alkaline or basic solution. Look at here, the pure water concentration of hydrogen ion is 10 raised to the power minus 7 and concentration of hydroxide ion 10 raised to the power minus 7. So both concentrations are equal, so we call neutral and it is pure water. Second one, if concentration of hydrogen ion is greater than 10 raised to the power minus 7, we call acidic solution. And look at here, concentration of OH minus is less than 10 power minus 7. Why? Because it will dissociate equally. Hydrogen and hydroxide ion both are equal, both concentration. Here concentration of hydrogen, this arrow means concentration of hydrogen increase. This arrow means concentration of hydrogen decrease. Increase and decrease you can take in sense of here. I gave you example before here on the board that before from pH scale less than 7 we call acidic solution, more than 7 we call basic solution, and at 7 exactly 7 we call neutral. And the third one here, example in alkaline solution, concentration of hydrogen ion is and concentration of hydroxide is both concentrations are given. Now come back to the next. If you want to this one define the concentration for both in acid neutral solution, in acidic solution, in alkaline solution, you can call the basic solution. The concentrations are same, 10 raised to the power minus 7. Thus, if hydrogen ion concentration is more than 10 raised to the power minus 7 molar, the solution will be acidic and neutral, or if less then solution will be alkaline. You can see this example, I will send you on your WhatsApp, and you can share these all values how it is acidic and basic. Acidic given here hydrogen ion, these all we call alkaline. Here hydrogen ion concentration we call acidic, and if 10 raised to the power minus 7 we call neutral. So all values are given here, you just compare with one. When water actually we use as a solvent and it can dissociate, so we call this one auto-ionization. Dissociation, ionization are the same. Both we can use when the molecules break down into its ionic form, we call dissociation or ionization. Both are same. And this more explanation for you, and I gave example also. Look at here the third point here. If water is only a source of proton means H plus OH minus. Proton only we call H plus ion. You can also call proton. Now, as we did before, the standard condition at the room temperature, what is the value of Kw? If you want to substitute, next we have the problems how to calculate Kw. So at 25 degree actually we can use this value. But if we change the temperature as we saw before one example, but here more examples are given to you. If we increase the temperature, look at your first column, when we increase the temperature, second column is the values given of Kw. So Kw value also increase. Look at the third column. Now I compare temperature with Kw and then pH. That what is the effect of Kw on pH value? If Kw increase or decrease, what do you think, that pH value remain constant or it will also increase? So at 0 temperature, pH of water is 7.4. At 10 degrees Celsius, 7.2, then we increase 20, 25, 30, 40, 50 and 100 degrees Celsius. Look at their temperature first increase at 25. as we did before here, this is the standard condition, room temperature. At room temperature, our values for Kw is this one and the pH is 7, exactly 7. If exactly 7, we got neutral water. And when we increase the temperature, look at now pH decrease. It means after the 7, solution is alkaline, basic solution. Before 7, an acidic solution. Now, we have some more examples, but let's say first we are going to define, and from the previous knowledge from grade 11, that how to define acid and base. There are two scientists here, first Arrhenius and then Laurent-Bronsted, that we want to define what is acid, what is base, because this whole unit we call acid-base equilibrium. So we must know and how to define acid and how to define base, because both definition we are going to use next our topic. So first one is, according to Arrhenius theory, an acid is a substance which ionizes in water to give hydrogen ion. As given there very clear here, first one, to give hydrogen ion, we call acid, and those substances we ionize in water to give a hydroxide ion, OH minus. So we call this one base. But the second scientist, and mostly we use this according to Laurent-Bronsted in this ionic compound. So according to this, acid are proton donor, those that donate proton. Proton means hydrogen ion, H plus, we call proton. And second here, how to define base according to Laurent-Bronsted is proton acceptors. It will gain proton. So here only proton, H plus. According to Laurent-Bronsted, there is no OH minus, same like Arrhenius, but here according to this scientist, acid and base, one is proton donor and another one is proton acceptors. So this is all about the acid and base. And before we did how ionic product of water, how we dissociate ionic product of water, how we ionize ionic product of water, then how to write the expression for ionic product Kw, and substitute here from the equation, and after that, this is the final equation for ionic product of water at 25 degrees Celsius, and its value here 10 raised to the power minus 14. The unit of Kw, how to calculate the unit of Kw, because we know the concentration of hydrogen and concentration of hydroxide. So concentration unit will be write mole dm cube. Here we also write mole dm cube. So because both concentration are equal, so the unit is mole and mole. You can write mole square into dm cube and dm cube here. So you can write just dm cube 6 power 6, because here minus 3 and here minus 3. So our objective, find out the unit of ionic product of water. This is all about today for ionic product of water. Next lesson we will study how to find out Ka, what is Ka, what is Kb, and then so let's see just for within for 1 minute. We will start from the beginning. What is our objective? We finish today. So the first one, this is our main objective, ionic product of water, and from your syllabus you can see and you are able to write now, write the dissociation reaction of water, write the expression for Kw, then work out its unit as I did here this unit. Work out its unit of Kw, and you can substitute the unit of concentration here, and then